Bonjour à tous. Hello, everyone. My presentation is about a multidisciplinary and multi-institutional environmental study in West Central Alberta, and more specifically in the Fox Creek area. For this presentation, I'll just skip the abstract. This project involves many people from the federal and provincial governments and university professors, as well as grad students. This project is supported by both the environmental and groundwater geoscience programs, and also by the Initiative on Cumulative Effects. The study area is located just southwest of the town of Fox Creek in West Central Alberta. It extends over 700 square kilometers. This area is mainly forested and unpopulated, so the only water wells belong to oil and gas operators. Fox Creek was selected for this project because it has been one of the most active regions for oil and gas production in Canada over the last 50 years. Only in this limited study area, there are over 800 oil and gas wells. The regional bedrock aquifer is located at the northern edge of the Pascapou Formation here, which is the most important groundwater supply in the province. It is a non-marine unit that corresponds to a complex succession of interbedded mudstone and siltstone and with sandstone channels, and that is known to contain some coal seams. The Fox Creek project has three objectives related to the three sources of funding. First, to characterize the shallow bedrock aquifer in the Pascapou Formation. Second, to investigate the integrity of the intermediate zone that controls the vulnerability of superficial aquifers to potential contamination that could come from activities at depth. And third, to assess cumulative environmental effects, including a general study that aims to identify existing challenges to make recommendations for improving the current process. 9 monitoring wells were drilled and logged 2 years ago. These wells were screened in shaly intervals as we wanted to sample more evolved, older groundwater. Some sampling was done right after drilling, but the full suite of analysis was done last summer. As we were able to establish agreements with 2 oil and gas operators, 13 water wells could also be sampled to improve the spatial coverage. Slug tests were performed in the monitoring wells and permeability tests in superficial sediments. For a master's degree on water budgets in both vegetated and non-vegetated areas, so areas impacted by oil and gas activity, such as along seismic lines, lysimeters, soil moisture sensors, rain gauges, and rain collectors were installed at 5 sites and samples collected each month. Snow density and thickness were also measured this winter on a monthly basis. I will now present some of the results obtained this year. For this master's degree on water budgets, only after 6 months of fieldwork, preliminary results show that the moisture content and soil temperature show quite large differences according to their location in highlands or lowlands, and of course to their depth, but also for a given site if the instruments are installed off or on seismic lines. Also, the first 6 months of data show that the local meteoric water line is parallel to the global meteoric water line, and that results from pore water here and groundwater in the aquifer are relatively well aligned along this local line. The lithological logs, among other things, helped identify the presence of a few beds with high velocity and density, mainly found in sandstone, that were interpreted as cemented. They therefore may represent barriers to vertical flow, but their lateral extent and the presence of vertical fractures in these layers are unknown. Downward flowing groundwater was observed in all the wells but one, confirming that recharge conditions are prevalent in the study area. Fluid pathways are interpreted, Fluid pathways are interpreted to be mainly along discontinuous fractures, but also through the sandstone matrix. The majority of open discontinuities or fractures observed in the borehole walls were bedding parallel, but only about 5% of these were interpreted to be transmissive. This slide shows that the potential hydrocarbon sources found in the cuttings from the shallow monitoring wells have not reached the thermal conditions for thermogenic hydrocarbon generation, as shown by pyrolysis and petrographic analysis. Although the possibility of microbial gas production associated with the organic matter in the coal seams cannot be discarded. The private wells and the monitoring wells have the same water type depending on their location in the watershed. Groundwater from most wells are of the sodium bicarbonate type, shown in pink, but a few wells located upstream have a calcium bicarbonate type, shown in green. Only 4 wells contain small concentrations of dissolved methane, all of microbial origin. This methane could be associated with the presence of coal seams that were observed during drilling. In these cased wells, groundwater generally contains very little or no tritium and has an uncorrected radiocarbon age value between 5,000 and 10,000 years upstream and larger than 10,000 years in the middle and downstream parts of the watershed, indicating that groundwater is relatively old for this small watershed, and therefore that there is probably some contribution from outside this surface watershed. These findings are also in agreement with the complex stratigraphy of the Pascapoul Formation and also likely confirm the presence of cemented beds that would prevent mixing of water from recharge below the upper 30 to 50 meters of the aquifer. A 3D hydrogeological model was developed in FIFLO based on the 3D provincial geological model. This 3D model is about 1 kilometer deep and includes superficial deposits, which are typically relatively thin, less than 30 meters. Hydraulic conductivity values and the recharge rate used in the model are comprised within the ranges found in the literature for these units, and also based on values obtained from our field and lab work. The difference between the simulated and measured water levels is considered relatively good. The understanding gained from this model will help in the development of a coupled surface water groundwater model, which has already started. The development of the 3D dynamic geomechanical model included the following steps. The generation of a discrete fracture network of natural fractures based on available statistics for the area. Hydraulic fracture modeling to create the induced fracture networks coupled with the reservoir simulation to model fluid injection based on data from the industry. And finally, 3D coupled reservoir geomechanical modeling to analyze fault instability. Results show that hydraulically fractured induced fractures during the different stages generally grow parallel to SH max, the present day maximum horizontal stress, and are stopped by orthogonal natural fractures, such as those shown in red here, circled in red. Results of the simulations also show that the bottom hole pressure increased by about 20 megapascal during hydraulic fracturing, the normal overpressure in the Duvernay Formation being about 60 megapascal at 3.5 kilometers depth. And that hydraulic fractures do not extend beyond the top of the Duvernay Formation, mainly due to contrasting geomechanical properties within the with the overlying unit, which is great news. Finally, results of the general research on obstacles and challenges to cumulative effect assessment that was based on interviews and discussions with consultants, federal employees, and First Nations groups show that although cumulative effects assessments have been a requirement of environmental assessments in Canada since 1992, several barriers remain, such as lack of data or problem accessing data, such as industrial data. Practitioners also deplored the lack of guidance for determining the scope of the study. For the First Nations groups, on the one hand, the fact that they are not involved in the whole process and in the final decisions raises a lot of frustration, although they hope that Bill C-69 will help. But on the other hand, the required and desired participation is often too much of a burden on existing resources in their communities. This study attempts to offer relatively simple and feasible solutions, but that will require a lot of political will and open-mindedness, from everyone in order to limit or maybe even remedy these solutions, these issues. These recommendations include, but are not limited to, legislation to make data publicly available, including monitoring data, the legal requirements to monitor certain data to be determined maybe according to a given type of industrial activity that could or should be used to reevaluate operating permits, maybe every 5 years. Third, consolidate all requests to First Nations within the federal government in one place to avoid duplication of work. And finally, developing long-term government plans, thus ambitious plans to conduct regional assessments in different regions of the country, particularly those with industrial activity, past, current, or future. Thank you very much.